In this tutorial, we will be discussing pure substances and formula units. When we compare the macroscopic world to the microscopic world, we're looking at things that we can see and can try to depict them with things that we can't see. So the macroscopic world is what we actually see, while the atomic and molecular world are the particles that compose the matter of what we can see. And the symbolic way is what chemists represent the atoms in the molecular world. So here we have a glass of water. Within the water we have billions and billions of water molecules, and symbolically we say H2O represents each one of those molecules. Pure substances may be either elements or compounds. Elements may be either atomic or molecular, while the compounds may be either molecular or ionic. So elements and compounds. Elements can be broken into atoms and molecules, and compounds can be broken into molecules and ionic compounds. Atomic elements are those that exist in nature with single atoms as the basic unit. Most elements fall into this category. Molecular elements do not normally exist in nature with single atoms as their basic unit. Instead, these elements exist as diatomic molecules, two atoms that are of that element bonded together as their basic units. The basic units that compose mercury, for instance, is an atomic element and a metal, and are single mercury atoms. You'll notice the picture, they're just little circles next to each other. The basic units that compose chlorine, a molecular element, are diatomic chlorine molecules. You'll notice the difference here. Chlorine atoms are being in sets of two rather than single ones as they are in mercury. Elements that exist in diatomic molecules are shown below. How I like to remember this is just a little mnemonic device I have. If you count these, there's 7 of them. So, if you look on the periodic table, they are right here, and it kind of makes a number 7. So, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I drew the picture too long. Alright, so it kind of makes the number 7. And then we have hydrogen over here. So it's like 7 star or something like that. And that's how I remember, I do it visually, what the diatomic molecules are. You do need to memorize those, though. Molecular compounds are compounds formed from 2 or more nonmetals. The basic units for molecular compounds are molecules composed of constituent atoms. Ionic compounds, which is what we're discussing in this tutorial, contain 1 or more cations paired with 1 or more anions. Remember, cations are positive ions. I remember this by the mnemonic device of breaking down the word cations. Cats have paws. Cations are positive. That's how I remember those. So I have another little mnemonic device there. And then anions will be the other one. Anions are negative. I've heard a couple of different people try to come up with different ones. One that seems to stick with people is that anions look like the word onions, and onions make them cry. And so it's a negative effect. And so those are just a couple of mnemonic devices of remembering which is which. The basic units that compose dry ice, a molecular compound, are CO2 molecules. Notice the carbon and oxygen are both nonmetals. That's why it's considered a molecule. The basic unit that compose table salt, an ionic compound. Notice that sodium is a metal, chlorine is a nonmetal. Sodium is positive, chlorine is negative. We have a cation and anion here, is the formula unit. Now, the whole depiction of metal and non-metal, being cation, anion, is a general rule of thumb. It's good for about 80-85% of the time. There are a few exceptions because the actual rule is cation and anion. However, when you put a metal and non-metal together, the electrons will exchange and you'll have a positive and a negative. So in general, if you have a metal with a non-metal, you're going to have an ionic compound and need a formula unit. When a metal, which is the tendency to lose electrons, meaning that it's becoming a cation, combined with a non-metal, which has a tendency to gain electrons, which means it's becoming an anion, one or more electrons transfer from the metal to the nonmetal, creating a positive and negative ions that attract each other. The compound composed of a metal and a nonmetal is considered ionic. The basic unit for an ionic compound is called a formula unit. Unlike molecular compounds, ionic compounds do not contain individual molecules, but rather cations and anions in an alternating three-dimensional array. Ionic compounds always contain positive and negative ions. In the chemical formula, the sum of the charges of the positive ions, the cations, must always equal the sum of the charges of the negative ions, the anions. And just as a review, here's our periodic table. The first row is going to be a positive 1, second row is a positive 2. Then you skip the transition metals because those change, and we'll talk about those later. Then we have positive 3. The fourth row can go back and forth, so it doesn't really do anything. And then minus 3, minus 2, minus 1, and 0. You need to memorize those rows. Write the symbol of the metal and its charge followed by the symbol of the nonmetal and its charge. Make the magnitude of the charge of each ion without the sign become the subscript for the other ion. If possible, reduce the subscripts to give the ratio with the smallest whole numbers. Check to make sure that the sum of the charges of the cations exactly cancels the sum of the charges of the anions. We call this the crisscross method. And we will be going over this several times through the rest of this tutorial just to make sure you understand. So if we take aluminum and oxygen, aluminum is here, oxygen is here. So if we look at the charges, 1, 2, 3, so aluminum is a plus 3, skip, minus 3, minus 2. Oxygen is a minus 2. That's where we're getting those numbers from. These are from the rows on the periodic table. You crisscross those numbers down to get Al2 from the oxygen, O3 from the aluminum. Let's do another one with magnesium and oxygen. Magnesium is here, so plus 1, plus 2. That's how we get the positive 2 charge here. Oxygen is here. Plus 3, skip, minus 3, minus 2. So that's how we got the minus 2 here. Crisscross, and we get Mg2O2. If this happens where they're both divisible by the same number, you're going to want to reduce it. So I'm going to divide both sides by 2 to give me a final answer of MgO. Let's try another one. Lithium is here, plus 1. Oxygen is here, plus 1, plus 2, plus 3, skip, minus 3, minus 2. So oxygen is 2 minus. Crisscross the numbers down, Li2O1, or just Li2O. We can double check these charges saying that we have 2 lithiums with a positive 1 charge, and we have 1 oxygen with a negative 2 charge. Notice that that cancels out to be 0. So our final answer is Li2O. Alright, so now we have calcium and sulfur. Calcium is here, sulfur is here. Plus 1, plus 2. calcium is 2 plus, sulfur plus 1 plus 2 plus 3, skip, minus 3 minus 2. Sulfur is a 2 minus. Crisscross the charges down, Ca2S2. They're both divisible by 2, so we're going to reduce it down to CaS. That means we have 1 calcium at a plus 2 charge and 1 sulfur at a minus 2 charge to equal 0. So our final answer is CaS. Potassium, which is here, plus 1. Nitrogen is here, plus 1, plus 2, plus 3, skip, minus 3. Notice every single time we have a positive and a negative. Crisscross, K3 in 1. So that means we have 3 potassiums at a positive 1 and 1 nitrogen at a minus 3. That's going to equal 0. So our final answer is K3N. And our final example, we'll have lithium plus 1 and fluorine plus 1 plus 2 plus 3, skip, minus 3 minus 2 minus 1. Fluorine is a minus 1. So Li is plus, F is minus, crisscross 1 and 1, LiF. Alright, so with ionic compounds, we have a